Hi everyone. Continuing our discussion of Unit 1, the scientific use of numbers, in this specific video I want to look at Système international d'unités. 4 years of French, still mangle the pronunciation. You all may know this as SI units though. And then later we're going to apply prefix multipliers to these units. Now, it's going to still take us a couple more videos to get to a problem like this, but we do see units here. We see grams and we see milliliters. And when you take grams over milliliters, what do you get? You get the property of matter called density. So let's take a look at these units and how to apply these prefix multipliers. A prefix multiplier in this case is milli. Okay, besides talking about SI units and their prefix multipliers in this video, I just want to remind myself that I also want to discuss exponential notation. And we are going to do a very simple thing called dimensional analysis, or a very simple type of dimensional analysis. We'll get into more complicated dimensional analyses in other videos, but I do want to introduce that here. All right, there are 7 SI units. But for now, I only want you to know about a couple, the ones that are going to be most important for us at the beginning of the course. First one is length, and we could label our column. How should we label our column? We should label it a quantity. So the SI unit for length is going to be the meter. And the symbol is M. The next one is time. That's the second. S. Temperature. We're going to use the Kelvin, big K. Big K. The last one for now is going to be mass. This one's a little bit unusual. The official SI unit for mass is a kilogram. So they are using a prefix, K, or let me just spell it out first. Kilogram, and abbreviation is kg. The other 3 are amount of substance, which is a mole, MOL is a symbol. Electric current is an ampere, A symbol, and luminous intensity, which is a candela, symbol CD. But for now, we're going to focus on these 4. Okay. There's one missing, and it's the one that we saw on that cover, which is volume. Volume is going to be based off of the meter, and if you take 1 meter cubed, you form a volume. And it looks like this, M3. But that volume unit is something that many people are not used to. I think most people are used to a liter. And it is now acceptable to consider the unit for volume, or the base unit, as a liter. But technically it's not part of the 7 SI units. So we'll just say plus 1. Okay. So this is 4 plus another 3, and then volume would be maybe the 8th one. We could think of it as the 8th. Let me just finish my thought. Or liter. Big L. Big L. You don't need to know this conversion right now or how to get this, but there are 1,000 liters in 1 cubic meter. At the end of this video, you would be able to do this conversion. Okay. All right. Next is prefix multipliers. You know, if we take a look back at the cover, see that's a prefix multiplier, milli. So we know what a liter is. It's a unit of volume, but now we're going to take a milliliter, and we have to figure out, or we have to know what that represents. Okay. Something that we all are familiar with is the centimeter. So we're going to take the base unit, in this case meters, and we're going to figure out what length is a tenth of a meter, is a hundredth of a meter, is a thousandth of a meter. And let me give us another table. Let's take the prefix. We're going to go smaller for now. And actually the first prefix that I want to go over is the deci prefix. Deci. What you're going to do is you're going to put deci in front of these units. Decimeter, decisecond, decikelvin. Again, this is a little strange. They don't use grams, but the SI unit is kilograms, but we are going to have, we'll see decigrams, and we'll do that first actually, as an example. So the symbol is going to be little d. And this is where it's going to be a little bit different than how a lot of you have learned this. We're going to use what's called a exponential notation. It's actually the multiplier, but the other name is exponential notation. And the exponential notation for deci is times 10 to the minus 1. So how do we use this? Let's take a look at an example. We're going to use this in conversions. And for instance, if we have 1 deci, and I said we were going to use, what did I say we were going to use? Did I say grams? Oh, we'll use grams. Decigrams. That equals, you take the number, 1, times 10 to the minus 1. And then you take we'll consider this the base. So when you want to convert decigrams into grams, let's say we have 5 decigrams, it will be 5 times 1 times 10 to the minus 1, or just simply 5 times 10 to the minus 1. So these two are equivalent. Let's take a prefix that you're even more familiar with. Let's take centi. We could do centigram, but I think you're more comfortable and you could visualize better centimeter. The symbol is C, and the exponent notation or multiplier is going to be 10 to the minus 2. If I ask you, what is the relationship between centimeters and meters? I think the vast majority of you, including myself, would say there are 100 centimeters per meter. But when you use multiple or exponential notation, I think this is a good technique to use, especially when we get into harder problems. You want to think of centi as 1/100th of a meter. And therefore, the example that we're going to use is 1 times 10 to the minus 2 meters. To remember this convention of using exponential notation, I put 1 in front of the unit that has the multiplier, or sorry, that has the prefix. And then I figure out what the base unit would be. Okay. Now, is it true? Yeah, it's true that 100 centimeters equals 1 meter. Okay. And you'll get the same answer whether you use this conversion, 1 centimeter equals 1 times 10 to the minus 2 meters, or if you use this conversion. But I think we should stay consistent, okay, and use the exponential notation. And I think this will be easier, or using exponential notation will make things easier when we get into harder problems. Because again, when I see the word centi, that prefix literally means 1/100th. And that's where we get 10 to the minus 2. Let's go to milli. I think once we see milli, you'll start wanting to use the exponential notation. So m, little m. We already have grams, we have meters. Let's use volume. And let's not use the cubic meters, let's use liters. Because 1 milliliter, if you want to visualize this, maybe the volume of the tip of my thumb. That's times 10 to the minus 3. So what is the convention again? The convention is put 1 in front of the unit that has the prefix, and then you could relate that to we'll call it the base unit. So how many liters are in a milliliter? Did I say that right? How many liters are in a milliliter? 1 times 10. We're going smaller, so that's another easy mistake to make. It's not 1 times 10 to the 3, it's 1 times 10 to the minus 3 liters. Again, most people know this as 1,000 milliliters equals 1 liter. Both conversions are correct, and you will get the same answer you'll see when we do dimensional analysis. It's just that, again, wanting to be consistent to try to minimize potential errors or sources of errors, I would rather use always the exponential notation and always put the 1 with the unit with the prefix. 1 times 10 to the minus 1, 1 times 10 to the minus 2, 1 times 10 to the minus 3. There is no 1 times 10 to the minus 4. We skip to milli micro. Another m. But we can't use little m because that's already taken up by milli. The symbol is the Greek letter, it's the Greek letter mu, mu, times 10 to the minus 6. I'm on the wrong line. 1 micro. What could we use? We haven't used seconds yet. Microseconds equals. So again, how would you apply the prefix multiplier? 1 times, there we go, 10 to the 6 seconds. So let me circle some of these just to emphasize how we use the multiplier. You're going to use it to get the number of base units. We'll go one more. Let's go to nano. Little n. I did it again. Wrong line. Times 10 to the minus 9. Where do we encounter nano? We encounter nano for nanometer. And again, put the 1 in front of the prefix. The wavelengths of light that are attributed to color, are measured typically in nanometers. So how many meters is a nanometer? There are 1 times 10 to the minus 9 meters in a nanometer. Oops, didn't mean to circle that. Okay, so let's say the wavelength of light is 650 nanometers. How do we figure out how many meters that is? Well, you just multiply that number by the multiplier. 650 times 10 to the minus 9 meters. Now, I know this is not conventional scientific notation, right? Conventional scientific notation would be what? 6.50 times 10. So the decimal place is here, and to get the actual number written out, you move to the left to make it smaller. 1, 2. So to get to 6.5, we moved it 2 times to the left. That means we only have to move to the left 7 more times. So these 3 are actually equal. That, and that. Okay. The other thing about general chemistry is you want to get used to your calculator and how to treat these exponents. And for my calculator, instead of writing times 10 to the negative 9, I use the button E. So let's literally do this calculation. 650, okay, hopefully you can see that. I have to do Shift EE, but it only shows one E. That stands for times 10 and then negative 9. Okay, so that's not conventional scientific notation, but look what happens when I press enter. It gives me this written out, and let me go back, let me do scientific notation. You see how it's 6.5 times 10 to the minus 7. So that value there, 650 times 10 to the minus 9, equals 6.5 times 10 to the minus 7. Okay. So practice your calculator. Calculator work. You don't want to start fumbling trying to figure this out during a quiz or an exam. Those are the ones that I would require my class to memorize in terms of getting smaller. Go smaller. How do we get bigger? And what do our prefix multipliers look like? If you're like me, and you study better off of very clean notes, definitely try to straighten this up a little bit. Yeah. But now we're going to go bigger, go larger. Prefix. First one is going larger. We go all the way to 10 to the 3, and that's the kilo. Symbol. Little k. Big K is Kelvin. So little k. And what do I have next? We have the exponential notation, or the multiplier. And there is no 10 to the 1. Oh, actually there is, but we're skipping that. We're going to go 10 to the 3. So your multiplier is 10 to the 3. Where have you seen kilo before? Kilogram, for sure. Kilometer, a unit of length. Let's do kilometer. 1 km equals 1 times your multiplier, 10 to the 3. If you have 5 kilometers, you have 5 times 10 to the 3 meters. Okay. Don't forget your units. Okay. Next is we'll go to mega. Big M times 10 to the 6. Megaton maybe. M ton. Again, the 1 goes in the way I like to do it, the 1 goes with the prefix, and then the multiplier goes with the base. 10 to the 6 tons. Next would be giga. And actually, that's as far as we are going to go here. 10 to the 9. Whoops. That's 10 to the 9. That's a billion times larger. 1 giga. Uh-oh. Very interesting. We're going to use hertz, which is a frequency. 1 times 10 to the 9, a billion hertz, a unit of frequency. Those are the 3 that I want my students to know as they go bigger. The last thing is an example problem. How many centimeters are in 5.7 kilometers? Question mark. Okay. Our final answer wants to be in centimeters, the unit centimeters. So I'll put a question mark here and circle it so I keep reminding myself I have to work towards that. This number right here is not a conversion. It's not one of these. It's not one of these. It's data. So we have data. The technique of dimensional analysis will help us convert one value into another. Some people call this picket fences because they use a fence-like structure when they do this type of analysis or type of calculation. I'll do it using picket fences. Start with data though. 5.7, always have units. So that's the tip or the trick. Start with data. Don't start with a conversion. I'm going to go a little bit fast, but I don't know the conversion to kilometers or kilometers to centimeters. I know from kilometers to meters. We want to cancel out kilometers, so the km goes on the bottom and then goes on the top. And this is why I want to use the exponential notation, because I don't have to think. It should be automatic that I'll put a 1 here with the prefix. So in terms of the base, in this case, we'll consider the meters at the base. Kilometers is 1 times 10 to the 3. And that's how you would use exponential notation. When you multiply these two values, you get rid of the km. But keeping an eye on the final target, I want centimeters. So now meters, centimeters. Many of you will say 100 centimeters for 1 meter, which is perfectly fine. You'll get this correct answer. But to stay consistent, again, for me it's automatic. I'll put a 1 with the prefix unit, and this is 1 times 10 to the minus 2 because Centi, in my mind, means 1/100th, or 1 times 10 to the minus 2. Your units cancel, km, km, meters, meters, and I like to circle the units that are left over, cm. Now practice the punching of the calculator. 5.7, enter, times 1e3 equals, so I'm doing this in parts. I'm pressing equal after each operation, divided by 1e minus 2 equals. It does give it in scientific notation, my calculator in this case. And then the units are centimeters. All right, there'll be a lot more practice with dimensional analysis and using these prefix multipliers in future videos, but that's a very simple introduction to dimensional analysis.